Hello and welcome to the NeuroTechSF Hack Night for December 9, 2021. We are getting perilously close to the end of the year. It is officially getting chilly outside. I don't know if you can see it very easily, but the wreath has been deployed from storage into the to the door. So very festive, and Santa, I think, is continuing to bring people cool Neurosity crowns in his sleigh. So all in all, things are good. So we have an exciting guest tonight, which I think is going to be a really cool presentation. We've got some really good discussion tonight around EEG data and so on. And I'd actually like to start off there. There's been a wonderful increase in conversations on the EEG data channel, which is really, really exciting to see. Oh, yeah, excellent. Morgan is here. So I thought that we could feature some of the conversations that come up. And Morgan, you're glowing again. In the best way.
Can you hear me?
Yes.
Okay, cheers. I will turn down my lights or something.
No, I'm telling you, your luminescence.
So,
I made
anyway,
a mess out of my headphones.
you keep going as...
Sorry for the... You know what? I'm going
I am... hi, Bruno. As I am coaxing a few more people to sign up at the meetup, because we are... I'm not going to say how many, but we're super close to 1,600. So, and yes, of course, there are big prizes. Big prizes at 1,600.
Nice. So this is going to be a very exciting hack night. So, all right, let's start with some really interesting questions that have been firing up. And Morgan, I see you were participating in these discussions, so we've got our whole community here as well. All right, let's start with the first question from Ben. Can you tell when an EEG is on the head versus not on the head? And can you also tell if it's being worn in different body parts than presumably the brain? So I think it's a very interesting question. My guess is the nature of the question. I think I saw a tangential intro that was talking about creating a device that does all day tracking of people and so on. So not in that sinister way, but like, you in the same way you wear a Fitbit all day and just tracks your health stuff. There may be devices that, integrated into your VR or as part of your headphones, but either way, monitor your brain state as well. So can we tell? Yeah, there's a variety of ways to tell, and the differences are going to be hardware specific. So I've got a crown right here. I'm going to go ahead and share. First, let me put it on. Yeah, yes.
This is the new Neurosity?
Yes, this is the crown. Okay. We are crowning it up. All right, so I think this is on a good fit. And as you can see, some electrodes for me fit better than others, but on the other hand, I get a pretty reliable 2 out of 4 on each arm. So I wonder, with the Muse, it's a 4 electrode. We always get one bad one for me in the front. The AF8 is always terrible and the AF7 is fine. But so I call it a 3 electrode out of 4. 3 out of 4 is going to be solid. And the crown, it's 4 out of 8. On my particular skull configuration. So, sorry, it is there. Right. Yeah, it is right here. Here is the crown going on. Yeah, and I declare myself King of Ireland. And yeah, just something I've heard people like to do historically. Doesn't end well. No, I'm just messing around here. So I've claimed my title, which is not a de jure title. It is just what I've conquered. Now I'm going to share the screen. Okay, so now we have the crown on, and we're doing that. And this is what the EEG data for the crown looks like. Now you can start to see a little bit of difference between the electrodes that have a good fit electrodes that don't have a good fit. So CP3 is fine. C3 is pretty loose. F5 is pretty loose. PO3 is fine. PO4 is drifting its way through amplification adjustment. F6, fine, and so on. So you can use this to kind of look at the raw. And the reason that I know C3 and F5 are not having a good fit is because that's what it looks like if I take the entire thing off. So I'm going to go ahead and do that. So here's the crown being removed. And soon, hopefully, we should see it pick up that oscillatory sawtooth pattern on most channels. There we go. And so this is the signal that a crown, that this particular hardware is generating when it's not on anyone's head. You can tell because it's a very specific pattern. It's atmospheric noise, so it's not going to be like 100% reproducible, but at the same time, you'll be able to know that this is when you're getting these kinds of readings, it's not on. And so it's this oscillation, it's the rapid oscillation between the two settings. It's that sawtooth that I would say is kind of the most descriptive. And that's why when I go ahead and put them on, and obviously there's going to be a little bit of noise, but as we get this to fit, now there's one more way. Sorry, I'll show this in a moment. The 1 over F slope, the frequency calculation in the bottom right has a very specific shape. It's flat on the curve. We've got a 60 hertz spike, but we're not really seeing any signal beyond that. So the other way that you can also calculate, beyond looking at the raw, is you can kind of look at the frequencies and say, that's not what I'm expecting to see. So when we put it on, we're going to see a bunch of changes from the amplifier. And now our frequency spectrum signal looks quite different. Now, there are times where that signal seems a little unreliable. Let me see if I can get a little better fit. How about this? Cool. So now it's, as you can see, when I start talking, the artifacts get really bad, but it's curved. You can see that the linear data is much more like what we're expecting. The power spectrum kind of normalizes when we're not actively talking, and we get this curved thing with the 60 hertz spike. So yes, you can tell when it's on, you can tell when it's off, and you would be able to tell from the frequency decomposition. I haven't really tried testing to determine, like, if you put it on your neck or your arm and the electrodes are getting a signal, what exactly signal they generate, but it should be different than the signal being generated here. Okay, then there was one more about artifacts, and I was thinking that we dive into that from Nikhil, and I think this was the thread that you talked about. Okay, so Nikhil had some general questions around if the electrodes are in the back of the head, you're not expecting to see as much noise when they're talking, moving their jaw, etc. What electrode placement is likely to cause the least amount of artifacts given, let's say, 4 to 8 electrode channels? And reference electrode or an accelerometer, what algorithms are useful? And for what? So I think there are, when one is trying to publish a paper that is going to be scrutinized, peer-reviewed, and potentially reproduced, one has to go for a very, very high level of precision. You want to try to get the electrode in the same spot. You want the stimulus to be the same. You want the subject to be the same. You want the time frame to be the same. You want all this because there are a lot of variations, and you're trying to minimize the variance and get the best data and all that good stuff. When you're doing prototyping with with BCI and EEG, I would say you can adopt a slightly different approach, which is, why don't I record and see what I get instead of trying to pick a method that's going to work for what I'm trying to do. And the upsides there, okay, so you don't know if you're going to be sampling in a useful spot because you just picked some number of locations. You don't know if there's something better about one site or the other, so you're kind of picking something in the dark. And then you're not sure, like, okay, does this mean it's going to be more susceptible or less susceptible? This is something that comes up a lot with the esports that we do. So people typically talk when they play competitive multiplayer games. Talking is jaw movements. Jaw movements are bad for EEG. So, what to do about that? But it even gets more precise. Talking with Brain Attach recently, they've got a spot right here that they're going for. And so they can actually go with, like, where your skin moves, don't put the electrode there because that's going to be the most susceptible spot. Their instructions are put it above and below that spot. So there's a couple of ways you can find spots, is what I'm trying to say. If you have a fixed hardware, then just go with that. Like, maybe you don't know if the Muse is or isn't useful to you, but honestly, just try it. And it turns out that the spots that the Muse uses was able to pick up the exact same signal that the Crown picked up when doing that spicy challenge. So the spicy challenge was kind of like an interesting test case for us, which is like, okay, we have no idea where this potential reaction to capsaicin is going to come from, what it's going to look like. But it turns out that from looking at the devices, it seems non-specific. It seems that it's not really localized, or if it is localized, that it's a strong enough signal that it's not difficult to detect. But basically, some experiments, that stuff isn't even an issue. Like with the spicy challenge, it didn't matter if the person had a Muse. It didn't matter if they had an open BCI. It didn't matter if they had a Crown. It didn't matter where those electrodes were, what the sample rate is, which electrode they were using, and what they did for artifact rejection. Because you could still see what was going on. So the main things I'll say is that in my experience from hacking around on low density consumer BCI devices, and I'll just show you some of the stuff, the side-by-side comparisons that we did for the spicy challenge. I kind of adopt the ethos that it's better to just deal with the noise and see what you get and use the clean recordings. And I get the sense that a lot of these consumer BCIs that are going to be, widely deployed and whatever, that is the method. Neurosity has a product version of this EEG, which is about, measuring focus and calm and productivity and so on. I don't think they really concern themselves with the fit, how well you're wearing that EEG on a given day. And I think it doesn't really matter because as long as you're putting it on your head every day and as long as you're roughly doing a similar task, there's going to be a lot of variation, but some of the channels are going to work. And this is all I'm trying to say. Like, if you're trying to do a one-to-one comparison of a channel because you've got a peer-reviewed study and this is what you're going to be forced to do, this might be rough. If you're just trying to ballpark it and say, yeah, do these look kind of similar? Yeah, they sure do. This one's a little different, right? But, I mean, you can tell it's the same thing. Whereas on this channel, you can tell that this was a bad fit on this electrode. And you can't even compare it. Now, it's an easy enough fix. You go, oh, well, I won't use that channel. Channel 3, also a little dicey. Why? We have no peak. And I also happen to know channel 3 is one of my bad channels on the Crown. So what do we do about it? Well, we could do complicated artifact removal, or we could say, well, channel 1 looks good. Channel 2 looks bad. We'll ignore channel 2. Channel 3 looks bad. We'll ignore channel 3. Channel 4 looks fine. In fact, we're seeing the same change that we saw on channel 1. So, it's not necessarily, I'm not trying to be flippant here, but honestly, artifacts are a problem in relation to how much you need precision. And if you don't need precision for whatever reason, you can still ballpark with whatever artifacts. Now, again, if you look at this configuration, 5 is a good electrode, 6 and 7 tend to be bad fits for me, although I think we got it, but like here, this one looks good. And then 8 is a fine fit, even though whatever. Here is kind of like, what do these artifacts look like in the power spectrum? Well, channel 2 is that dicey one, especially on this day. And what you'll find is that basically, even though these electrodes are kind of all up here, right? So they cover different brain regions. For the sake of this particular experiment, they really look quite similar. So the blue and the gray are almost identical, which are channels 1 and 4. Those are the good channels that I tend to get on the crown. And then the other ones have variants. The purple, channel 3, and the orange, channel 2. Channel 2 is kind of elevated. I don't trust it. Channel 3 kind of like lower. That seems like it's a signal issue. And then if we look at the other recording, well, geez, we can't even compare 2 because here it's in this own universe. 3, again, has kind of like less signal than the others. So we're going to trust 1 and 4. Depending on your purpose, this may or may not be sufficient. But it may be that simply from picking a hardware device and picking a method and trying the experiment, you find that there are a consistent 1 or 2 channels that do what you need them to do. And you can use those to start your investigation. Now, of course, once you have an idea of what you're looking for, you may want to clean things up and remove blinks and understand which electrodes are sensitive to what and so on. But really, when starting with consumer BCIs, my suggestion is start with the device first. See what you can get out of it. See how it performs. See what electrode consistency you're getting. And once you have a good idea of that, then you can try to go into artifact removal and cleanup and so on. And there are many, many, many methods. And here's like the floof calculations and whatever, where you can see the different things. You can try to deal with this. You can try to like non-destructively clean this up. You can try to use artifact component analyses and whatever. But ultimately, if you're just hacking, if you're just trying to get familiar with your data, if you're just trying to come up with an experiment and see if you can create a contrast, you may be better off just using whatever your best channels are. And as for Amalia's question, what's the best way to handle artifacts in an automated way? My suggestion is standard deviation. EEG signals should not have a huge amount of variance in the crown is a little bit different because it has active electrodes, and so it's going to drift a lot. But ultimately, you're looking for spikes. You're looking for things in your data that are anomalous. And typically, anomalous things will be some number of orders of magnitude away from your actual data. So you can pick a threshold depending on how strict you want to be, but let's just pick 4 orders of magnitude to start. And anything that's 1,000 times greater than the rest of your data on that channel within the last few seconds probably isn't valid data. And so you can just reject that. Now, a big rat hole that we went into is like, okay, when you delete the data, do you concatenate it, do you whatever? Save you a few months of investigation and just say, my answer is delete it. And it's the least destructive. And if you're looking for a method of like, what does delete mean? You can either zero it out, or if there's like, a rolling mean that you can set to 0 or whatever. But ultimately, like, the best way to handle artifacts is to not handle them. And you can tell from the voltage when something is unusual. And again, like here, the power spectrum kind of indicated that, you know, which electrodes are trustworthy, which ones are not. But like in terms of, can you recover that purple signal? No, I wouldn't. I would just redo the experiment. I would just, you know, whatever. There are going to be electrodes that have different levels of sensitivity to artifacts. So just like we were saying earlier, you know, there's going to be some parts of the head that are more affected because of the way the skin sits on your scalp. But you're going to if I was going to do like a spicy study with a crown on myself, you know, what I would do is basically just say, okay, I'm going to be doing these recordings. I'm going to have 4 clean channels. I'm going to come up with a pipeline that's going to make it fairly easy to do my comparisons. And then I'm going to just get my data and go from there. Let's see. The last one, ICA. So I'm not, you can use ICA. I think it's more for higher density EEG, and I think it's more for epochs and trials, but you absolutely can. If you're just hacking on consumer hardware like Muses, OpenBCIs, or Crowns, don't be put off by the fact that you may not know how to implement artifact rejection. In fact, let me just kind of give you a really, really simple, if you're using MNE, like a bandpass from 1 hertz to 45 hertz is great, except MNE's implementation of bandpass is weird. So ultimately, if you can narrow your range to between 1 and 45 hertz, you're probably in good shape. Why 45? There isn't a good scientific reason. 50, you'll start to get European voltages, interferences, etc. 45 just means it doesn't matter if you're US, Canada, Europe, anywhere else. You can just assume that you won't have too much electrical line noise. If you want to go up to 55, that's fine. Depending on the device, you may start to see changes in the signal as it gets close to the thing. But it also kind of determines on like what you're interpreting. If you're not really looking at gamma, there's just, or high gamma, I should say, there's really, really little just means you're going to have to fight through the electrical range for your device. And then once you're past that, you can continue to interpret. You'll also start to hit diminishing returns in terms of like 60 hertz, 70 hertz, 80 hertz. Like that stuff tends to get cut off by the skull. So for a whole slew of reasons, like if you're just looking for a frequency range to analyze, I would say 1 to 45 hertz will get you 90% of what you want, 95% of what you want, and will exclude 90% of what you don't want. So I'll just say, you know, the bandpass implementation in MNE is weird. What do I mean by that? Like it doesn't really cut outside those frequencies, it rolls off. And the roll off is very mild. That's great for a bunch of reasons if you're trying to do that kind of analysis. But if all you're trying to do is say, I care about 1 to 45 hertz, it's not as great. Notches work relatively well, but you have to define their width and the central frequency. And so we kind of use notches heavily along with specifying kind of like frequency ranges for analysis. So I would say, like, if you're just processing your data, start looking at that, start looking at plots, start looking at quantifications. And yes, eventually you'll probably want to do some stuff with artifacts, but really you can do a lot of analysis just using whatever clean electrodes you have and using whatever clean data you have in that config. And I think that's it for, sorry, Morgan, did you want to add in anything, your thoughts on EG artifact analysis?
I'm sure I have nothing to add. Bandpass implementation is the bandpass weird? Sorry, okay. I've continuing to just post things on social media and see, yeah, but I haven't 100% been listening. I do love the Crown. I love a Crown live demo, and if yeah. And so where are you getting these questions?
Oh, the EEG data channel on Slack. You were on the conversation. Yeah. You were talking about you were answering some questions from Nikhil.
Oh, is this the question? Yeah, okay. Sure. I mean, I pointed to some papers. I punted. But I do like that. I like that, meta pipeline package. And, for when people are asking about like, what order of operations should I be using? I wasn't quite sure. Did you get more details in terms of like, were they already collecting data? What channels, what was causing artifacts? I saw somebody else replied with a great set of like practical things about like, if you're railing the ants, then like, just throw that data out, and like all good stuff that I don't even think about saying, but like, yeah, like you're not going to be able to recover that. ICA is not going to save you if you saturated the amp.
As someone who a few years ago was getting familiar with EEG processing from the outside, I can tell you that when people get directed for how to process, analyze, and interpret EEG data, for whatever reason, filtering and artifacts is like the first thing that they get directed into. And I think that there's a very valid, it's going to be at the front end of your pipeline, so you should think about it at the start of your pipeline. That's like super legit. But I also think it creates this impression that if you don't have artifact handling and removal, that you're not going to get useful data. And I guess the only thing I'll try to say is, yeah, but you can use plenty of your data, even if it's what you consider bad. Like, there's nothing wrong with doing exploratory collection and exploratory analysis off whatever electrodes work well. And of course, you eventually want to get a solid design that minimizes artifacts, and then you remove them with ICA and your high density and whatever. But like, I mean, if you just want to know what something does, I mean, slap on an EEG and see what you get.
Definitely. And I would say, I mean, and this comes to some degree from what Devesh did with ERP Core, right? Mm-hmm. So he wanted to compare, like, ERP Core is a data set that UC Davis released. It's really nice in that, I mean, it's actually somewhat like the data set that Jody's gonna talk about, in the sense that like it's an EEG data set on the same subjects, but in like 6 different paradigms. Okay. Mm-hmm. And like 30, 40 subjects, and they've got more, but they released 30, 40 subjects. And then they did like what we would call kind of manual artifact rejection processing,
right.
And he started looking. I mean, in particular, because it's a lot of data. Started with just this mismatch negativity, but it was funny where it's like he wanted to use the ICA automated component identification cleanup, but prep as well. These like EEG lab compatible pipelines, and which he did. But then it was like, hey, have we even just tried taking the raw, not the raw, but just averaging it. like how bad is that? And how much data were they actually throwing out that was, plus or minus, I don't know, like 200 or something, like, microvolts or something. And how much were they losing to blinks? And certainly, it was really interesting, right? Because now mismatch negativity, as people might know, you actually give people kind of a distractor task. So some people read, but you're doing something while you're listening to these tones. And, blinks weren't really correlated with the design. It wasn't like you were seeing something flashing on the screen or, so you weren't anticipating when something was going to appear, and you weren't blinking with that anticipation or anything. And it averaged pretty well. And if you had a few blinks in there, or head movements or something, like it wasn't really destroying your evoked potential. And it's definitely worth seeing. And when I think about like testing amps back in old EGI days, we had this one P300 task that I could put a net on myself. Just wasn't grand, but with like 10 minutes of data, electronics everywhere, and I could get a nice class difference between X's and O's when I was pressing a button to X's, I think was the task. Yeah, definitely worth trying. And anyway, you are muted.
Thank you. I agree. It's my standard spiel of being muted, of just basically saying, look, yes, in a university setting where you have 128 channels and you have grad students and you can pick your location and you can pick the thing and you pick the perfect design and you have the perfect subjects and you have them for 2 hours just for a 15-minute recording. It makes a lot of sense to be that particular about which electrodes you're using and how you're measuring and the fitting and making sure that the gel has good resistances and whatever. And then for the people that are just using consumer hardware, and the only reason I take that assumption is just from the nature of the questions and from the nature of like the discussion. It seems like yeah. And so my thing is like, don't get too upset if the locations are in a place you're not expecting. So many people thought the crown would be kind of not helpful being back here, but it's perfectly usable, right? And even though the muse is here and here, we can compare the data between the two and see the same thing.
There's right here is that electrode spot. Yeah.
I mean, so the way that the electrodes, these four, and you can actually see with a little redness where they contact. So it's these spots, and then there's two on the back.
Gotcha.
And I think one of these, I think the lowest one on the arm is the reference. Sorry, go ahead.
Well, no, I was going to say, I wanted to point out again the upcoming data challenge, the collecting data from yourself, December 15th, I believe. And I will post something in the chat here. Am I supposed to be posting that? I forget. Or am I supposed to wait until this 15th? It's coming, but the EG notebooks, whatever headset you have at home, if it doesn't already work with BrainFlow, get in touch with Andre because he'll probably make it work with BrainFlow. And
hey.
Yeah,
I don't mean to interrupt, but check this out. We're going to be posting this soon. I thought you might find this interesting. But we are using our BrainFlow, like right now, this crown data that you're seeing is coming via BrainFlow. So if I go to the console,
Yeah.
I run my Neurosity in local mode, but then I run in BrainFlow mode. So we turned off LSL, we enabled OSC, and that's how BrainFlow works. And then over here, I wanted to show this is the Python script that makes the magic happen. So this is the BrainFlow Python code where we basically import BrainFlow, pandas, NumPy, all that stuff. Here is the Crown board. This is so basically we hook up with all the Crown related stuff. Here's the list of channels, and we're hardcore about timestamps, so we add another one as well. This is the LSL stream. This is where you build it, you give it a unique ID. We're using our internal code names for silly stuff. Don't mind me. Then here's where you define how many channels, the sample rate, the format, all that other stuff. You can query LSL and get all this later. And then basically, we push a sample every 4 milliseconds for some arbitrary period of time. And this is what that looks like. If I have our plotter running, there's no data because it's not running. But if I fire this script up, kablam, we are now BrainFlow to LSLing.
Nice.
And this is it. So this is the Python script that's offending Andre's sensibilities right now and pushing those BrainFlow packets to LSL. All right, sorry for that quick diversion. But I'm hoping to post that on GitHub in some way, shape, or form somewhere in the next few weeks.
Great. We need to see more of that. And I don't know. So this year, have you had either of the Neurosity guys on?
No, we really should.
I think they would,
Oh yeah, no. I literally haven't thought about asking him. I know AJ went up to Canada to do the assembly of this last round of batches, and he was really busy with that. They've scaled up to 50 units a week, and I'm not really sure if that's like a high volume. That sounds like a decent amount of.
Well, given that they've previously made them all themselves. So I remember that one time that AJ showed us like all the various form factors they went through.
Right.
Yeah. So sorry, my dog is being demanding. Yeah, that's great. So we should ask Alex or AJ to come join again.
I definitely will.
Talk about the new stuff and push that for the data challenge. But have you tried EEG notebooks with that?
No, but I didn't know that EEG notebooks is BrainFlow enabled.
Yeah. Wow. I mean, that was the big. So I mean, with EEG notebooks, I mean, let's call it EEG notebooks 2. Because EEG notebooks was originally very much a Muse project, right?
Mm-hmm.
And Muse LSL was essentially the method to collect data, and that was that was what Alexander Barachon had, right?
Right.
The new version was really adding BrainFlow support, and which then gave us, numerous devices, right? With all of BrainFlow's, so that was the way to get OpenBCI, right?
Mm-hmm.
And that was obviously the big thing, as they are really pushing this project forward. And but it does give you other devices, and you've talked about the Neurosity way of doing things, which Neurosity is just a little bit different because, of course, they've got an onboard computer So they can, as you saw, just with the dashboard there, you can essentially change what the device is streaming out. In addition to, it also has the benefit of being a Wi-Fi device, and so it doesn't have any of the Bluetooth connectivity problems, or at least, and also like long-term recordings. It's
Yes.
it's more. It requires more power, but you can't really beat the reliability of Wi-Fi.
I have to say, from a pros and cons of using this thing, what I've finally come on to is the best way to use it is leave it on permanently. Just leave it charging when you're not using it. The connection is stable. It works fine. It doesn't get into like hung states, which is sort of my expectation. I'm always having to restart everything. But the fact that you don't have to worry about that really does make it convenient. Like, you don't pair it, you don't mess with it. When you want to do an experiment, you put it on. The only limitation is past an hour and a half, because of the Wi-Fi, because of the computer, you're going to start getting low battery. So like 2 hours, I would say, is the absolute limit. But I suppose if you have two crowns and you're willing to swap them, then you could get 4 hours out of it. But yeah, it is a very different product. I think it basically sits next to your computer, and whenever you feel like EEGing, you put it on. Sorry, go ahead.
Well, I was just going to say, can you run it with power cable?
It goes into sleep mode when it's charging, so I don't think it can charge. And
that's what I thought. That's what I thought.
Right.
So
yeah.
You saw Manuel asking about BLE. I mean, it is the short answer.
It is better, and I can tell you the difference between Wi-Fi and Bluetooth in terms of power use is crazy. So if you're not streaming off this with the small battery, you can get about 8 to 20 hours. If you are streaming on Bluetooth, we haven't fully tested it, but I think it's looking like 2 to 4 hours. If you stream via Wi-Fi, 20 minutes of battery time on the default battery.
Yeah, we got to do something. Well, yeah.
So Wi-Fi is a lot better than BLE, but 10 times the power use.
Yeah.
Sorry.
Those record, but you'll never lose connectivity during a 10-minute scan, which could happen.
Yes.
I'm not saying it will happen, but and certainly we had a number of issues with the Muse LSL, and that was, I need an update on the Muse LSL stuff, because I know that Hubert was actually working on a different kind of back end in terms of I forget the Bluetooth. Well, so we had issues getting Muse LSL to work with both. Okay.
Maybe had a question. Let's. Sorry.
Sure.
Oh, it got deleted. Okay. Morgan, I'll let you field this, please.
So this is a project that was really spearheaded by OpenBCI, and they got IEEE Brain involved, and then John ran with it in terms of it gave us a kind of focal point for EEG notebooks specifications. And that it is a set of experiments that you can run with EEG notebooks. You can run on yourself with consumer hardware, but this allows you to collect ERP data that is, like a Cogneuro experiment. So there's, the N170 houses and faces. There's a visual attention task. There's an auditory steady state task. I should actually catch up, and we will. Well, please check out EEG Notebooks project on GitHub, because the thing to do now while we have time, is to actually check and see if your device is compatible.
Yeah, so maybe
Yeah.
since we have our guest in a bit, maybe it's not a good thing to dive into, but I would like to maybe for next week, let's
Yes.
do the Crown to EEG Notebooks BrainFlow thing.
Sure. Well, I think what we can focus on for next week is really the data challenge, and you know, maybe we can coax John back for
we can get him to walk us through. Hell, we can even submit a data challenge.
That's right.
Sorry, go ahead.
We can do data collection live.
Let's do it. Let's do it. Yeah, that's perfect. Okay, so we'll have John. I think it's a great idea, Morgan.
I think that would be awesome. So John is currently, I mean, actually, we're lucky that we get Jody tonight because right now a lot of brain stimulation people are in Charleston, South Carolina for the 4th annual Brain Stimulation Conference. Yeah, so I know John's there because he hosted a session today for whole brain computational modeling of brain stimulation. So I'm really looking forward to hearing about that. And yeah, lots of great presentations, lots of great presentation pictures on Twitter today. I don't know if they're recording all the presentations, but again, like hopefully we can coax John back for a synopsis of that meeting, which would be great, amazing to hear. And yeah, so I'm trying to think of the devices. What other devices? What are the other big ones that we get? Oh, the GTech Unicorn is also a supported device with BrainFlow.
Yes, and I verified that it works using their included dongle.
I mean, that's yeah. They've got their own. I mean, they ship a dongle and they do but it's great to have support from them. I mean, they other companies, they charge for connectivity, but they don't seem to be giving us any hard time about having a connection path there.
They do have an actual LSL thing that they put on GitHub, which is separate from the BrainFlow implementation, but we could not get that working. We couldn't. So I'll only say that it was written a few years ago. It seems to have been abandoned. It's a C# project, which is cool, but it doesn't do much. However, the BrainFlow thing works perfectly. You plug the dongle in, you install BrainFlow, you put the right board ID, and you can hook into the data stream really. It looks exactly like that Python thing that we just did with the Crown.
Sure. So Manuel, I am not exactly. Let's just say big prizes.
Well, here at NeuroTechSF, we can sweeten the pot.
Yeah.
I don't know. Morgan will sing.
Yeah.
And I'll wear a Santa hat.
I will sing. Is that what? Okay.
Yes. Yeah.
Agreed to that too quickly. Yes. But I am happy to sing. I will sing a Christmas carol. And I'm not sure, but I do believe that there are some prizes. It was kind of hard to work out because the big part of this project really is getting people to submit data, and then by submitting data you get access to the group data, and so certainly a big part of being being a data collector is that you will have a great data set to play with, a great group data set to play with. And what we really want to see is, of course, have some of these data sets, or have these data sets be good enough that we want to also have them, say, in something like MOAP, and be able to test algorithms and things with it too. but let me check on the progress of that and see what's. I know that the website is still being worked on because I can. Dimitri sent me it's still got some Latin, which I don't think we're intended to support Latin as a language. I think that was filler. So yeah, but please check out, and tell me if you've got a headset that we don't have support yet for. So there is an emotive compatibility project that I've talked about before called Scikit, spelled CY. And I would love to see emotive equipment be supported. And I mean, I'm not sure NeuroSky really makes it, but if there are other 8-channel systems or 16-channel systems that I'm not thinking of, yeah, please let us know, and we would love to get some data collected from that. Other news this week, of course, it's a big machine learning conference, and we are expecting to see lots of great, deep learning and other machine learning algorithms finally make it to play with on GitHub. I don't know if, I don't believe there's I know there's a big machine learning for health, but I haven't been focused so much on the deep learning for EEG. If there's any neuro-IBS, just talking about the machine learning this week, in addition to the brain stimulation conference. Those are the big conferences. Right. And
yeah, the machine learning with EEG is actually the toughest thing. It's the toughest thing you can do machine learning on because of all the transformative steps involved. With all the other devices, skin response and pupils and whatever, it's just a straight, like, here's the values, here's the pattern I want you to learn. Oh, you found it. It's wonderful. You can use easy architectures. It's so simple.
Yeah. Sorry, Manuel has another great, yeah. So the NeuroTechX primer, or the neurotech primer, is out. This is a work that has been going on. It's a labor of love from a whole number of people, a whole set of people that were, really a part of getting NeuroTechX off the ground, and Sydney in particular. And yeah, it's really exciting. And please, if you haven't already seen a link, then have we already? Okay, great. So yeah, get one for the neurotech geek in your life. Get some for your family, and yeah, should be great. I haven't actually seen everybody who's got a chapter, but I wouldn't be surprised if John's got a chapter in there too. Anyway, it's great to see that after so many years. And okay, so let me check Slack for if there was. So I know Ryan's, yeah, I mean, what I've really been looking at are just, TMS modeling and TMS, randomized control trials, and, TDCS. A big emphasis of the meeting has been, using multiple coils and using multiple TDCS locations. Big part. I mean, everybody's still kind of in awe of the SAINT study and rapid TMS and its efficacy in depression, which is So I'm certainly seeing that brain stimulation lab at Stanford is going through a lot of growth, which is awesome. So hopefully we'll get to see what's like an order of magnitude numbers in terms of those. I'm definitely going to ask Jody about her take on that, since she's in psychiatry and is focused on depression is one of her application areas. I mean, I think she's using it more for looking at task and behavioral effects, as opposed to using it as a therapeutic intervention. But maybe she'd have something to say about that. And certainly in terms of modeling, again, I think it's really interesting to check out the Reddit RTMS and TDCS subreddits, just because you see what I see, which is a lot of people using stimulation and talking about their experiences of it, and wondering if they really need the fMRI localization to be able to get the kind of SAINT results. I think that's a really open question. It's kind of disappointing that we got that they did that together with the change in the kind of the power and frequency of the stimulation, just because it would be TMS is still not a very focused stimulation. So I wonder how much, again, I'd love to see what people who are doing it with a task that is very localized, so if anybody had a chance to, I posted the papers that Jody linked as background, and I wonder how important the targeting was for having the effects that she was seeing. Although it was really nice to see a memory effect. And let me just check my mail. Okay. So like last week, I caught the this week I again caught the OpenCV community call, and last week it was nice because it was Control Labs talking and not revealing any new information. Oh, hey, okay, there's Jody. But it was nice to get that overview of body sensing from Control Labs, and also hear about how they were holding out for, like they weren't on a timeline to get a product, but it was very much this is the product that we want to get. Like, how much money and how much time do we need? And just check OpenCV's YouTube channel. Yeah. And so this week they had it was a what they call it, RoboFlow. So it's somebody trying to do CV software as a service for you. And the way it came up for me, at least on Slack, was the person asking if anybody knew a development engineer to build their own headset to compete with the Motive. And
oh yeah, I saw that question.
And I wanted to say, after coming off the OpenCV call, I was like, for your minimum viable product, why don't you start? You want to build an app, right? Or what they said on Slack was they want to build this app, and so the headset seemed like it was really not their main concern, and certainly, why not get started with the app first? And maybe they already are. Did anybody reply to that person? I didn't. Let me see. Where's the? So. I don't think Marcelo, right? Marcelo Geffen. Okay, William. Okay, so William Croft posted, Cody Rawl talking about headsets. So this is a very professional YouTuber. I haven't actually watched this. Calls himself Rogue Psychiatrist. Okay. And he's definitely got an open BCI there. Good. But I don't know if Josh is on. But anyway, my comment was going to be, have you tried OpenBCI or FreeEG32 and just get something? Or, actually, didn't Josh show you an 8-channel system last week?
Mm-hmm.
Yeah. So you could do something that a much lower cost and just get started, as well as, I don't know how much they've thought about where their electrodes need to be and things. But
should we invite?
Joey,
Yeah.
I thought you already had.
No, I wasn't. I didn't want to jump the gun, but
please. We said, yeah, and we need to be very. We need to be careful with her time. I know we're cutting into her family time, and so we're sending you an invite, Jody.
Mm-hmm. It should let you. All right.
Yay!
Hey guys, how's it going? Can you hear me?
Yes.
Awesome.
Great. Okay. Well, thank you so much for joining us this evening.
Of course.
Yeah. So for those who don't know already, Jody Mishra is a professor of psychiatry and is the director of the neuroengineering and translation labs. Yes.
That's right.
Yeah. And I love the papers that you sent. So which of those are you going to talk about today, or is that both?
Yeah, well, I'll talk about both of them, and
Okay.
It's a pleasure to be here. I've known Morgan for many years through UCSF, so it's great to be coming back, and it's great if you guys will be building more headsets for us to apply in clinical population.
Well, and I loved that you're using mBrainTrain. So so as part of NeuroTechSF Paris, we've had the CEO on, and that's a great device. So
yeah, we really like it for the kind of it has really high signal quality for the cost for deploying multiple systems. So yeah, we really like it.
Well, afterwards we're gonna ask you some follow-up questions about that. But
sure, of course. So
turn it over to you.
Great. Should I share my screen? And and
yeah, there's a little laptop icon
great.
above your.
And then let's see. Yep. And feel free to ask questions as we go. Okay. Let's see.
Yeah.
Great. And hopefully you can all see the screen and everything.
You can.
Okay,
Yes.
great. So yeah, I wanted to talk to you about the papers that sent out where we're trying to combine neurotech and wearables and apply machine learning on the data to really get at aspects of personalized mood prediction. Okay. And so Neat Labs is, wow, the recording went really quiet pretty suddenly, which is, I think that's good. Hopefully I'm still on and everything.
Yes, we muted so that it's just you.
Okay. Okay.
If you need an irrelevant comment to verify that everything's working, I'm here.
Yeah.
Okay.
I didn't want my dog to bark too.
Yeah, I was like, wow, that was so quiet suddenly. Okay, so we're the Neat Labs, and our goal is really developing new neurotech for mental health, and we believe in both engineering and translation. So we have a bunch of neuroscientists, engineers, and clinicians coming together. We also, given the kinds of diverse, job foci that people come with and the kinds of backgrounds, we also have a very heavy diversity focus, and we make sure that strong ideas around diversity are commonly discussed in the lab. And our goals simply, where we started off are that we represent mental health with data. You've all seen, the representation of the glass brain, and that came out of the UCSF lab that I was at before. And essentially, we don't think about when we think about mental illness, specifically mood-related disorders or any other disorders, people just give a certain threshold above which a person has a clinical disorder versus not. But in reality, we all go through periods of ill-being and well-being, and it's really a continuum. So we want to be able to measure the brain state, but also everything that's happening to the individual around the brain state, which might be how they're stressed, how they sleep, eat, exercise, and also, cardiac rhythm, respiratory rhythms. They're all very important in how individual cognition is functioning at any given time. So this is just showing the sort of the crudeness of our mental health system sometimes, in that with just some subjective symptom reports that a patient might project at any given time, sometimes doctors would make a diagnosis about what they might have. And in this case, they're making a diagnosis about a panda in the DSM-5. So naturally, given this kind of subjective practice, we have disorders such as depression, which many of us may be familiar with. It actually is 350 million people suffer from it. In the US, 1 in 5 people suffer from it. 60% of those with depression also have an anxiety disorder alongside. And frankly, current standard of care, which are medications, only work in about 30% of patients after, and basically 70% of people don't get better after a certain medical treatment, and they go on to recurring treatments. And currently it's not just medications, but they're also FDA approved transcranial magnetic stimulation therapies and so on, but they also have this kind of remission rate. So we want to do better than that. Basically where we're at, and this slide is showing you that this is not really going away. In 2010 we had a burden of 22%. Now we have a burden of 35% in mental disorders. So what we really want to do is really bridge this gap about all that we know in terms of the complexity of the brain, and and the contextual complexity of the brain in terms of how the brain performs in different contexts of an individual, and apply that towards reimagining depression care. And so we need to be more data driven, not just about certain subjective reports about the individual. We need to have treatments that are more evidence-based. They must be scalable, which is what brings us to use of tools that are cost effective and yet give us research grade signal quality, which is why we're just chatting about the brain train equipment. It is one of the equipment that's out there that is highly scalable. So we use that in clinic settings and also in community settings and so on. And so it allows us to record in many different environments, cost effectiveness that I touched upon, and the tools need to be rapid. So if you're thinking about, engineering something that's actually a clinic might use, the doctor-patient time is very, it's very expensive. It's also, patient is there for brief periods of time. You don't want to create extra burden. And so naturally, what you want to deploy has to be rapid. So thinking about this, and given that I was trained as a cognitive neuroscientist, one of the first things we did when we launched Need Labs was to develop a cognitive suite as such of very core cognitive control domains that would measure various aspects of cognition. In this case, conflict processing, which is a very simple flanker-like task, working memory, which is a delayed response task to identify an item that you remembered and whether that item was in a certain location or not. And impulsivity, you're responding, but then you have to withhold your response. Emotion processing, how do you respond faces with different kinds of emotions on them? And rewards, how do you process information when it has certain amount of weight associated with it in terms of the dollar value. We're also interested in aspects of internal attention along with external attention. Internal attention is actually just very simply breath monitoring is how we monitor internal attention, how consistently you can do that. And some of our more recent work that's coming out is showing that that's actually very important to tell people about how their cognition might be working. If one can perform consistent internal monitoring, that's a very good marker for how one might perform on external tasks as well. So we generated this tool set. Essentially, it's a Unity-based tool set, and we generated it to function within about a 30-minute time frame, so we really fine-tuned the number of trials and whatnot. And our goal really was that, can we map it alongside EEG-based recording? So, of course, there are many other cognitive batteries that are out there, but I never got a cognitive battery that would also time sync with an EEG signal and that would be readily deployable on any kind of software and that I could take on a mobile platform and so on and so forth. It's like, okay, well, the first thing we do is we generate a battery like that. So not only that, so Ali was my grad student and then went on to work with Kernel, now works in, I think he works at Brain Products now, and he's an advanced engineer there. So he's a very talented guy. And he basically also developed an entire EEG source signal imaging pipeline. And this is a tool he developed called the SIM-BSI tool, the brain signal imaging tool. And in that tool, he advanced source localization processes. So this is traditionally when one performs source localization, one uses these local autoregressive averaging type approaches. They're called Loretta. And with that, you can get a source solution in cortical space. Usually, these kinds of approaches tend to have a limitation in that they put the hyperparameter plane, which is shown at the bottom here. This can lie in the brain space or outside the brain space. Of course, anything that lies outside the brain space is not biologically possible. So Ali came in and provided these Bayesian constraints on top of this source space, such that data that either the lead field matrix gets localized onto the brain space or is marked as belonging to an artifactual space. So he performed this two-stage process on top of the Loretta algorithm and called it the sparse Bayesian procedure, which you'll see that this kind of pruning of the irrelevant sources then leads to a more focal solution after his source localization is performed. And so essentially, we started applying this kind of source localization on top of the EEG source imaging that we were doing. And in essence, what we ended up with is that now we can think about scalable cognitive brain maps. And what I mean by that is that, okay, now we have a system that that will provide us information underlying cognitive tasks. We can take this information from any participant, take it in our backpack, go to a clinic or a community setting, and get reliable information, which is what the papers talk about, that this data is reliable across test, retest recordings. But essentially, you across these different tasks, selective attention, response, inhibition, conflict processing, and so on, what I'm showing here is actually just a representative map of one participant out of, say, 500 that we've recorded until now. And the way this activity is being represented on their cortical surface is that the mean activity would represent the age-normed activity of individuals in that specific age range, and that will be sort of this light green in color. But wherever this individual is outside the norm, so for example, their motor activity is slightly outside the norm in certain tasks, and it can really illustrate how certain activity patterns can be outliers for any one given individual. These are still not artifactual outliers because that kind of artifactual cleaning has already been done. But if one can readily see here that in the cortical space, this person has some lesser processing going on, especially in the parietal regions and in the lingual regions and so on. So this kind of analysis now lends itself to individual brain maps, and one can think about, hey, could we target something that is that can change processing in these specific brain areas that this individual is showing atypical processing on. So, and this is work that also I did at UCSF at the Neuroscape lab, many papers, which essentially say that there is a concept around taking brain activity in a certain brain area, and that brain activity is linked to a specific cognitive function. And if you were to actually challenge that cognitive function in a closed loop system by designing cognitive modules that challenge that particular brain system, you could actually change activity in that brain region and in that brain process in a very targeted manner. And there's several papers that we empirically showed this evidence to be true, which can be looked up. These are all sort of past papers on the NEAT Labs website, but the concept can now be applied on an individual level. So that is one way we thought about advancing scalable brain mapping, but our ideas didn't quite actually stop there. And what we wanted to do was that we actually just don't want to know just about the brain state, but going back to the slide that you've seen before, we want to understand what's happening in the person's life beyond the brain state, because that may depend on all these different aspects about how a person's eaten, sleep, had their last night's sleep, and so on. So this is a project where at UCSD we collaborated with the Professor's Day at the School of Engineering. And in this one, we basically took and Dakshin, who's also trained at UCSF, is my husband and also is co-director at NEAT Labs. He's the psychiatrist on the project. And essentially, what we wanted to do was not just understand, the clinical subjective skills that people answer. We wanted to give our brain and cognitive function assessments, and then use app-based tracking and also wearables. So basically, everyone had a smartwatch that was given to them, and really help us monitor all of these different aspects of, what an individual is going through. And we did this for a study. This was the second paper that I sent out. It was a 30-day period in depressed individuals. And the goal of the study really was that, okay, can we take all of this data and, mind you, create N-of-1 machine learning models. So an N-of-1 models is that we're just taking data from that given individuals and trying to make predictions on the data for that individuals without actual comparisons with other individuals. And why we'd want to come to N-of-1 prediction would be so that we can then say, if a given individual is suffering from depression or burnout in a certain way, what are their underlying predictors depending on all of these different things that could be predicting them, and target them to an existing evidence-based treatment in that domain. So actually, if you look in the literature for depression, there are, sleep-based trials and physical activity-based trials and diet-based trials and so on, and mindfulness-based trials and so on. And what you'll see is that all of these work to a certain extent, but there's no trial out there as of yet, but we're gearing up to begin that early next year, where a person could be, put in either of these arms, depending on their actual data and their mood fluctuations and what their mood fluctuations are being predicted by. So in general, when one thinks about machine learning, one usually takes a nomothetic approach. A nomothetic approach is when you take a given individual and you compare their data to the data of other individuals. And this is where you need, tons and tons of data from thousands of individuals, even to figure out where a given participant may cluster relative to everyone else and what their characteristics may be like. We actually did not take this approach at all. We take a different approach, which is called the Ideographic Nf1 Approach. So the Ideographic approach is making predictions on a person's state depending on their own prior states. So we're not like I said in the previous slide, we're not comparing against other individuals. What we're doing is we're taking the mood fluctuations over time. So that's why we collect this data intensively over 30 days. So the mood fluctuations that a person goes through over time are basically our entire time series. And we say, what is that mood related time series predicted by in the underlying things that we're monitoring for that person? And we do this separately for every person without actually comparing them to other people's data. Of course, in time, once we have much larger data sets, we can do these cross comparisons and hybridize them with the ideographic approach as well. So that is also possible. We didn't take that. We only took the ideographic approach in this paper because it was mostly showing the principles of how this can be performed and still give us high accuracy. So this is in the paper how the data from these different modalities is taken, and the main sort of the problem step that happens in all of this is taking all this data coming in from different devices at different sampling frequencies and aligning them to the mood event that happened right around the point of these data. So every timestamp in these different data are aligned to a given mood timestamp that is closest in time. And that's really one of the most sort of painful steps in the whole process because of the data coming in from different devices and so on. And then on top of this pipeline, we said, okay, well, we'll also apply machine learning. And in machine learning, as you may know, is not really just one procedure. It can include many different types of algorithms. So we said, well, we don't know that any given person, it's not necessary that a linear regression model would work best for them. It could be that a given person may benefit from sort of the decision tree-like models. So we said, let's try a suite of different kinds of machine learning models on each person. So this particular pipeline actually takes in all these different kinds of models, which are the random forest, gradient boost, and boosts are all ensemble learning decision tree type approaches, whereas the other ones are more linear type approaches. And then there's also a voting regressor that can choose upon the the features that are selected by these individual approaches. And the point really is that, every person's data, given the kind of distributions that it might have, there might be a particular machine learning model that may give you better predictions than the rest. And why should we, really say that there's only one kind of model that we should apply to all of the different subject types that we might have? So all of the models are also, we apply aspects of hyperparameter tuning, we do cross-validation schemes, and basically all the steps that may be necessary to protect from overfitting of the data. And then we apply this Shapley approach, which is basically to help extract what kind of features came out as predictive for any given individual's mood. So taking this pipeline, this is kind of the kind of outcomes it might give. So this is for one participant, the P1 here on the top, showing you the actual data and its fluctuations, and the predicted data and the fluctuations in red. You'll see that it's not perfect. If it does match about 80% of the time is what we see. This is a histogram on the right side plotted for the same time series data on the left. And there's another prediction on the bottom for P20. This is overall. So basically across these different individuals, we see high, this is a correlation coefficient for how well the actual data and the predicted data correlate with each other. And for pretty much everyone where the confidence intervals don't cross over with zero, those are highly significant correlations between the actual and predicted case, except for, say, one given individual. Here, we don't see that good of a good of a fit, and that's because this person didn't end up giving us that many great time points for prediction. They actually had a grievance event during the time the data was being collected, and so they had very sporadic data points that they were providing, and these sporadic data points also ended up being mostly a depression rating of 1. So there was neither that much variance in the data, and also there was the variable that we were trying to predict didn't have that much variance, and also it was sparsely input by the participants, so the model did not work in that case. So there are obviously these limitations that one can also work on in future cases by encouraging participants to provide their mood reports and whatnot. But this is quite encouraging for a first pass for this algorithm. So essentially, through this pipeline, what we were really trying to get at was that, okay, well, let's take the top most predicting model for any given person. The topmost model will be the one that has the least error. So the ones that have mostly around above 75% or 80% accuracy, or less than 20% error, are the ones that we're choosing. And for those models, we'll say, okay, what were the top 5 features predictive of that participant? So here we have P1, and we'll see that for this person, we had aspects of their anxiety was related to their depressed mood, which was true for most of our population. They had comorbid anxiety and depression. Anxiety was the highest predictor. And then beyond anxiety, for this specific person, the way they walked or had their physical activity was very much a predictor of their either well state or depressed state. So the distance with which they walked, the speed with which they walked were all high predictors. Also, how much caffeine they had was also an interesting predictor. So actually, when they had less caffeine, the blue is like lower feature values, they did better. They were positives more depressed. So more caffeine made them feel better in this case, and it would be a certain cups of caffeine in any given day and whatnot. You'll see that for P20, actually, the results were very different in that in this case for P20, the predictors that come up are actually how they walked, but also how their sleep was the prior night. So how many hours of sleep they were able to get. Another sensitive factor that came up was This is specifically reward related. GL bias is gain loss bias, which is a reward related factor in the DLPFC area, which is dorsolateral prefrontal cortex, a very important area, which is hyperactive in depression and so on. But essentially what you'll see, what I'm trying to contrast with these two people here is that the kinds of top features that one would get for targeting are very different from one person to another, and which opens up the way to test these features in a closed loop system and say, hey, if we were to perturb these specific features, in this case, exercise for this person, in this case, probably a sleep and exercise-based plan that's also emphasize sleep as much as exercise, say, would we get outcomes that drive improvement in mood or not? This graph just shows us that across all the people, we got different predictors in all of these domains. So for some people, diet was a high predictor. So this is the number of times diet was a high predictor was, 10 out of the 14 people had diet as a high predictor. Breathing and stress came up in half the people as well. So mindfulness-based therapy would work for half the people and so on. So these are the top ranking predictors that came up differently across different people. So essentially, this I didn't want to give a long talk. I wanted to actually just present that much and take questions and all of that. But essentially where we're trying to go with all of these different kinds of precision assessments is keep them scalable and non-burdensome, but then try to build a system that is closed loop in nature and ask whether that can actually lead to behavioral mood-related improvements. And that's actually a translational question, but also a basic science question in that, where all of this predictive modeling is telling you certain predictors that still, given the nature of the models, are correlational. And if they really are predictors, then they should, if you were to move them in the right direction, the mood of the individual should change as well. So that kind of basic science question is built into that as well. That's just scope of one stream of projects that we're doing, and this is just a few snapshots of our group, and we're happy to be able to do the work in California, but also in other parts of the world. So I'll end with that, and I'm happy to take your questions, and I'll just stop sharing.
Cool. So questions around the EEG stuff. When I looked into the mBrain train, I was also impressed with their signal quality. It looks like a lot of their hardware is based around the wet electrodes and the sponges and so on. So can you give us a rough, for people that haven't done these experiments, when someone comes in to do a battery of tests, can you kind of walk us through how long in total they spend and like the setup for the individual devices, and then basically, like if it's a 30-minute battery, is it like a 60-minute thing? If you could just walk us through the details of how they get like set up for all the devices.
Yeah, so it's about exactly. It'll take a 60-minute session in total. We actually do digital consent, so people can do that part earlier, and then they can still come in. And I do have a video of a setup if anybody would like to see that.
Oh yes, please.
Let's see.
If you're willing to share it, but that's the.
Yeah, sure.
We have a lot of people, I think we have a very diverse community. And so some people are grad students and students that are working on labs and are familiar with it. And some of this is like hackers considering their own projects. And so I think it's wonderful if we can just show them like, here's how UCSD does it. I think that kind of demystifies it a bit.
Sure, happy to. So I'll just share what it looks like. So essentially, so hopefully you guys can see this video.
Yes.
Okay, so these are essentially the sponges that come with a smarting headset, and this is one of our RAs. She's just filling saline solutions. You wet them in place. This is the system just getting turned on, and it's a Bluetooth connection in the new version.
Oh, this is the same software Wearable Sensing used to distribute to me. Sorry, not that it matters, but they were using the same Bluetooth interface.
Yes, they had the same Bluetooth, and so now Brain Train has made it more integrated with their setups in the newer systems.
Okay, gotcha.
But in the previous versions, they had this, which we still use because all our caps are not like the newest caps. But essentially, say these are the channels that would come up when you turn on the setup, and they're all going to be.
That's the impedance checking.
Exactly.
Yeah.
That's the impedance checking step. There's a participant putting on a cap. This is how the cap looks like. There are all these positions in the cap that are that's where the saline soaked electrode will go. And we work with many systems like the Cognionics or the other ones that are completely dry, and we've never been able to get as good a signal quality as the wet system. So we really like the saline soaked version rather than obviously the gel one is much more gunky, and participants they just don't like getting all that gel on their hair, and it's not as fast also. But essentially you'll see that this is also like a wireless system. Now she's putting on she's just cleaning her ear to put on the reference electrode on there with the reference clip. And then basically after this, she's I think they're gonna plug in the let's see, so there's the reference clip, and that's going to go on the ear just to say there's the reference where there's no signal. And let's see what's going to happen next. We're going to that's the amplifier. So that's the Brain Train amplifier, which is going to go in the back right there. And and then basically, then she's gonna put in a sponge electrode into each of those, and just clear the hair out of place, and put in a sponge electrode in there, and that will be basically what she'll do with every one of them. And nice. Here she's trying to fix the impedance on one of the channels, and after some time, after checking, she's checking the impedances, and let's see if the video goes all the way or not, whether she can get a good signal. But I guess she didn't show the green channels, but we wait till the channels are green. But, and this is where she's making sure the signals are coming in from our cognitive suite, and also from the they have the markers from the cognitive suite, and also from the EEG as well. And then
so this is lab recorder.
Yep, this is lab recorder.
So this is LSL directly to XDF. That's cool. Yep, that's
exactly
very exciting.
Yeah, and we the Unity sends out LSL port signals as well. And it's great because we then put in all the, we have other sensors like the heart rate sensors or respiration sensors. They all have LSL output onto lab recorder, and that's how we do it.
That's wonderful. Sorry, please.
Well, no, I was just gonna ask. So Brainy, is that an open framework? I mean, can other people use that to do things? Yep.
Yes, you can. We don't currently have. I mean, if people are good with coding, they can obviously with Unity coding. Yes, they can also add tasks to it. But currently, we've not had that kind of activity. Yes, you can use it.
Is this on GitHub?
Yes, it is. Yes, it's on our Need Labs GitHub. Yeah.
Great, because it is. I mean, that would be particularly nice as. Because you can deploy on mobile,
right?
Do you have that on iPads, or
yes?
I think you said Win 10 in the paper.
That's where we do the because the smarting is Win 10 limited, but the software itself works on all platforms. Yeah.
Gotcha. Okay.
The machine learning classifiers that you're using are awesome. I've been pedaling to Morgan, these N-of-1 classifiers work really, really great. And we've had the same discussion, which is if you're actually trying to make a multi-person large classifier, you do need a large data set. There's no question about it. And that's related to like the Child Mind Institute data set and all the other stuff that we were talking about there. But if you're trying to train for one person and you don't need to resolve inconsistencies, those ML models work really well. And we did a bake-off with a bunch of ML DL, and it seemed like it was quite equivalent for a lot of tasks, like the ML being a lot faster. So have you ever heard of a company called Divergence Neuro out of Canada?
No, tell me more.
So that's this company that is, sorry to bring up the Neurosity crown, but basically it's a clinical practice for therapists and depression. They give one of these $1,000 devices to the patient to take home with them. And they do a 30-minute recording every day. The data goes up to the cloud, and the therapist monitors their state and, you know, makes changes to the treatment based on how they're doing. So it's a slightly indirect version of the research that your lab is performing, right? And it's more of a commercial application. But with theirs, the therapist is monitoring the data, taking that information, looking at the patient situation, and making decisions, right? What to focus on, CBT or behavioral measures, sleep, exercise, etc. How do you imagine, are you looking at research, or are you imagining someone reviewing and acting on this information, either the patient themselves or a provider?
It's all in the research space right now. We don't anticipate immediately anywhere in the clinical space. You know, maybe with multiple clinical trials. The point is really, getting at, we try to collect a lot of different kinds of variables in a short period of time, because there's no really a holy grail that there's just one marker for a given person or a given disorder. So I think that's where we all want to build towards, clinical utility, but right now it's geared in the research space.
Yeah, I have the last question, and then I'll yield to anyone else who has questions. For your sleep and exercise, are you using like a Fitbit?
Yeah, well, in this study, we used the Samsung watch, because it was we have like a consortium with them where we are able to get their API data freely.
That's what I was going to ask. Like, how did you get device full data? Because I'm looking for one. The answer is we have a relationship with Samsung.
Yes.
Well, okay. I mean, so this is one of the things that Open Humans is really useful for, right? Is that you can, pretty much go to Open Humans, ask about your device, like, I mean, that's how I got access to the Apple Watches.
That's perfect.
Is that they make a collector for you, and Open Humans will also let you use their Jupyter Hub. If obviously you've got resources, but for people who are literally like, hey, I'd like to see my Apple Watch data.
That'd be great.
Data, like, you can go to Open Humans and go to their GitHub, and they'll explain, download this app, and that will give you the access. And then you're less kind of reliant on, or then you have more options.
Yeah, that'd be great. Yeah, I'd definitely check it out, because our next study is really about that, like taking this more scalable to people who might have their own watches, and also trying out the treatment plan with their whatever data they're able to provide. Because in this study, we just stopped at making the models, because that was the goal, really. But yeah, I think that's really valuable input, Morgan.
Well, again, Open Humans did all the work. It's great place. So, yeah, I mean, 2 terrific papers. I mean, you crammed so much into those papers. That was a week's reading in those, for sure. And can you say a little bit? You didn't talk so much about the TMS, and I know you're not really trying to use TMS as a therapeutic intervention. Right, you were looking at the interaction with the task and the TMS, but can you say a little bit about like what you did find that was useful in there?
Sure. Yeah. I mean, so we are interested in TMS because just like in the actual, one of the slides I was showing you, that if you were to find a certain kind of brain area that might have atypical performance, then one could think about targeting TMS stimulation, excitatory stimulation to that brain area. So that kind of, we are interested in treatment that way as well. One of our current trials also pairs TMS with cognitive stimulation of DLPFC through, cognitive training type application, and seeing whether we can enhance efficacy or whatnot. But in that paper specifically, we just had people come in for one-time TMS, so either excitatory or inhibitory TMS. And the question we were asking there was basically, can a Brainy as a platform pick up differences if it's done pre-post TMS, and also can it pick up different outcomes when it's paired with one kind of TMS versus another kind of TMS. And the paper showed that yes, we could. Even so, it was very short-term plasticity. It's like a single session, so the person's doing Brainy right before and right after, and they're randomized to one or the other 1 week apart. So in the paper, we showed that it's not just a platform, but it's also sensitive to short-term plasticity, and also gives us reliable data because we could check what happens to the baseline from 1 week to the next week. So we could compare the pre-sessions on 2 weeks apart, and also compare the pre-post in each session. And we showed, reliable outcomes both ways. And so the TMS part was more about showing leveraging TMS was just about, showing that it's the plasticity is capable of measuring plasticity with the Brainy platform. That's okay.
This is what I was afraid of.
That's cool.
I had two super quick questions as well, after promising that I was done with the questions. Have you tried using like the Empatica or GSR or EDA as one of the metrics?
Yeah, I think that'd be great. We have not yet, because we haven't gotten much that's LSL compatible.
Right.
And also, the Empatica is, like I said, we just went with stuff that's actually, is that LSL compatible?
Yes, this is the Emotibit, and now it's not available for sale yet. It's in beta production, so like February, March. However, it's $200 to $400. Has 3 PPG sensors, has the GSR EDA, which you can see here on the thing.
Awesome.
Bluetooth, Wi-Fi, has an SD card for remote connection. Anyway, really nice, because the Empatica was like this $2,000 GSR EDA wristband, and this is like a $400. So it's really, really nice.
Awesome. So so you'll see that in one of our future studies, because we need that kind of equipment to be, scalable across many, participants, and easily, we can acquire data from it. So thank you. We'll do that next.
Well, that was going to be my question, in terms of what would you like to see, or like what hole is there in kind of data collection that you'd like to see, but don't have things that are at the right price point for the scaling, which is,
I think a lot of these, so we find that in the wearables, like at least the wrist ones, really some of the more even like the $40 the Amazon watch. It's like you don't have to actually have a face. You can actually just, with the band that's $40, you can do a lot. But and they're actually not just the Amazon watch, but there are lots of other ones. If you search online, you can get like these. They have like this other Yame watch, which is $20 or something. So there are many such options available, but it's like having the data stream available to you. So maybe Open Humans has a good interface for that. So we'd want to look up that more. Also, at home, high signal quality wearables for the EEG would be great. I know Emotive would like to be one of those, but it's not really there yet in terms of home quality, good data. I mean, I know Muse and all are there, but they're, you really don't get whole head coverage. So, so that kind of,
They're not, yeah, and they don't seem interested. I mean, like that's not what they've turned
Right.
really to meditation and sleep
Right.
and
Right.
I mean, what about this? What about sleep data? Have you seen these papers from Boston in terms of getting sleep age and that as just an example of like something that seems relevant for psychiatry.
Yeah, I think that's definitely very relevant. So you're talking about sleep EEG based data, or
Yes, they're taking sleep recordings and
right,
then trying to do the same thing that some of the fMRI and MR people are doing, where it's
right.
like, hey, can I guess your brain age from this? And
Yeah,
then if there's a big mismatch, then that puts you into a high risk category and
right.
or something. But
Yeah.
I mean, Muse S. I don't have one, but I know John Griffith's been collecting data with those.
Yeah,
I
I think
plan to buy one.
awesome. Yeah, I think the at home neuro variables, I think would be very interesting. With cognition, with sleep, it's all like a really the new frontier. We want to go
I
with
mean,
things that are more accessible as much as possible, but yeah, we just have to keep our eyes out for it.
the cap is still the big problem. Or
Yeah.
what you were doing, and again, I love the mBrain Train equipment, but it's still a research system.
Yes.
Yeah,
Yes.
yeah.
Yeah.
And I don't think neuroelectrics is still. I mean, it's still pretty much the same.
Yes.
Yeah.
Yeah. Yeah. Neuroelectrics even I think a slightly higher price point as well.
Yeah. I mean, as
So
well as being research grade, and it's. I mean, maybe you want that extra money for the injection as well, but so I want to be cognizant of your time because I know I can start to hear kids in my age. You don't do any prediction about treatment. I mean, so you stay. I mean, like Alto Neuroscience and Emmett Etkin's lab is doing. They are getting away from kind of giving diagnosis as as a label, but getting at treatment response, which seems somewhat like what you're. Yeah. Did,
yeah, we're building upon that. So kind of data sets. I mean, these are all, the de novo data sets, and that of course we've had prior papers where we've looked at, say, like, there's their big NIH consortium data sets already out there where which you can use to predict substance use or a future your risk for certain kinds of development of substance use or alcohol use disorder and whatnot. What you're talking about, we're trying to do that with the Brainy platform, and of course that data doesn't exist right now. So we're doing that with Brainy and current, how people will respond to antidepressants versus TMS and other things, but that's all ongoing. Specifically of interest is severe depression and suicidality. Like who will actually, in that population that's really high risk, who will benefit from getting the treatment and who will not, or who needs more intensive care. I think we would want to know that better. So we're focusing some of our efforts on that. But again, that's more cross-sectional prediction in some ways, because it's a one-time neurocognitive marker or set of markers telling you about whether this person will have a good improvement, or will they be more complicated. So for that, you need a large data set of multiple individuals to compare with. So we're working on that. But yes, treatment outcome prediction is of interest for sure.
and how many people have you run on Brainy?
Right now, like about 500.
Okay. That's
Yeah.
good. So, okay.
One last question about if people were trying interventions, would they be excluded? I've heard about people trying TACS to improve their depression symptoms. Do you have anyone that has participated in your study that might have tried such a device, or would that have automatically excluded them? And I'm not trying to say like you would have whatever, but like, have you had anyone that you think might have tried such a treatment or you wouldn't have observed the effects?
So you're asking about whether if they've done brain stimulation before. We usually in usual protocols, you have them wait for about 3 to 4 months. And if they're still presenting with symptoms, they are very much eligible to participate again. Wow. It's obviously hard to, if they've gone through a certain kind of treatment and immediately after, or obviously never in parallel, because you don't want to complicate what your results are driven by. But most trials, not just ours, allow re-entry after 3 to 4 months.
I've wondered that for the longest time. Thank you so much. Sorry.
So you've got a couple of projects on GitHub. So Brainy's one. I think I saw PEB. Is that right? So that's your source imaging?
Yes.
And yeah.
That's in the Brainy paper, the source imaging that we apply with the sparse Bayesian second step added on. That's in PEB is on there. Yeah. Yeah. Any other projects that you're looking for help in that people can use? And yeah, there's not on the Neat Labs website that you will also find a link for a SimBSI, which is basically
the Simulink.
Yeah, that's the Simulink based brain imaging tool. It basically is like, you're just a GUI based, connectors of different LSL processes and whatnot. And even the analytics is a GUI based. And I think it's just a fun one to play around with and to get basic processing in place if you don't want to sit and code through all these different kinds of things. So yeah, that's a fun one too.
Gotcha. Yeah. Okay. Well, thank you so much for your time.
Of course.
Really appreciate it. I know we're up against the holidays too. And yeah, the amazing work.
Yeah, thanks guys. And I'll keep looking forward to things you guys post. You guys already brought up a lot of resources in this actual talk. Do you ever post them online on your forum?
Yeah, the chat log is available. Then there's like the Slack and whatever, and then we try to provide. But yeah, sorry.
And yeah, we can get. Well, I'll send you links when Alex posts the YouTube.
Okay. Yeah, I think like the things that you talked about, like the Open Humans work, or like even you showed some hardware. I mean, I think that just came up right now, but I was wondering if you have a website where you actually list these resources. That would be awesome. But I could just come back and check in a few months and see, hey, is your device available? Can I use it now?
So yes, and if you go to the if you become a member,
awesome.
You go to the Hardware Hub, you can get 10% off.
Great.
I mean, but there is a kind of educational part to NeuroTechX's website that's supposed to have a better breakdown, a more up-to-date breakdown of devices and things, which we need to update.
Okay.
But you are helping light a fire under us to get that done.
Yeah, awesome. Well, I'll look into your membership and things as well.
We're messing around. It's just like in email form.
We'll get you links. Because we'd love to see this. And well, and in particular, I mean, this is exactly the stuff that I love to see. Translational work for psychiatry is amazing, and anything we have, we'll try and get you links for.
Yeah, well, I mean, if you want to think about our lab, it's mostly we get all the cheap equipment out there, as long as it's not going to burst into participants.
Right.
We're gonna put it out Put it
we're
out
going to
for
keep away from like
patients.
maker boards and you know, but there is some really great wearable stuff that's coming out.
Yeah.
And you know, I mean, it's amazing what's going on in terms of the miniaturization right now.
Yeah.
And you know, Kernel lit a fire under all the equipment manufacturers, right?
Right. Exactly. Exactly.
It was great seeing David Boaz get this tear down, you know, do the tear down
Nice.
of things, you know, the FNIRs and things, and OPMs as well. But we would love to put you in touch with anybody that is making cool stuff that we know about. But Open Humans is great. I mean, because it's a community kind of quantified self people, but also researchers. You know,
Okay.
people from CRE, the Paris Center for Interdisciplinary Research.
Okay.
Doing great stuff. And you know, I mean, I'm kind of wondering about like how much you would be interested in, you know, kits for doing physio for like, you know, blood, saliva, other things, you know, and I don't want to take your time, but you know, in terms of trying to capture, you know, inflammation and things,
Yeah.
you know, and you know, what are the cheap ways of doing that testing and letting people do that testing at home and things. But
Yeah, exactly. I mean, we hopefully, well, I'll check it all out and you'll see it in our future papers.
great.
Cool.
Thanks.
Well, thanks, guys, and thanks for having me. It was so fun.
Okay.
All
Take care.
right, you guys. Bye.
Okay, and yeah, that I mean those. Well, Divergence Neuro too. I mean, I love, you know. I mean, that's kind of what I wanted to say to the Marcello, the Marcello Geffen on Slack. You know, in terms of like, yeah, I mean, it doesn't have to be a open BCI system, but you know, Neurosity's making at the same price point a 8-channel system that collects
It's fully
data.
self-contained.
Yeah.
And I never know which way to steer people, because it's like whichever archetype I guess that they fit into, it's always the opposite. So when I think it's like an engineer that just wants to get the data and I recommend the Crown, then they want the flexibility. When I think that they want the flexibility, I'm like, okay, try the OpenBCI, and then they struggle with like the getting everything going. So it's kind of like, I guess I would say that there's two great devices. One that gives you all the flexibility, fully open source, gives you granular control over the electrodes, the placement, whatever. You don't really need anything fancy for OpenBCI. Scotch tape and gold cup electrodes work great for, you know.
Yeah. So is Josh on?
No, I don't see Mr. Josh here. No.
Only because I thought that he could speak for Dimitri. But you know, that's
well, I mean,
electrodes is what Dimitri's been using, and I mean, he's opened up to the kind of more the I hate to call them spikes because that just sounds painful, but prongs, you know, the electrodes. You know, something that's more hair friendly, right? And and did Josh talk about the fact that they've put into fabrication a 128 free EG 128 system?
Well, they talked about wanting to stack it and all the component stuff and how difficult it is with the shortages to. I think they're working through it. But it seems like it's coming along.
They got 3 128 systems coming, or it's coming. And, you know, in addition to the chip that they were using in the free EG32 is the one that is gone, that is currently out of stock, and there is no restock.
Exactly. Yeah. Now it's
but he's been working with a cheaper chip. So and supposedly still getting decent data. This is why I would love to see them collect the EEG notebooks task data from the data challenge, because there's no better sanity check than event related potentials, and against a research system. And you don't have to get the same data, but if you're still getting a decent class separation on mismatch negativity, or faces houses, or these kinds of tasks, maybe the input impedance doesn't need to be, can be an order of magnitude or two less, and you can still get that data. These were the kinds of things where, that 25 years ago, people told electrical geodesics, there's no way you'll be able to collect data from subjects with 50 kilo ohm impedance.
Right. Well, the spicy challenge for me, the big surprise was the rear electrodes on the Muse pretty much showing the same data as the Crown. Now, obviously, the signal levels were different, and the voltages were different, and the quality was different, and which parts of the band come through over the baseline is different. But I mean, it's the same. I would draw the same conclusion looking at that data, right? Which is, oh, something's happening, and it's happening right here. So retroactively, I'll say that having done a bunch of studies with the Muse at Ole Miss University, and then here with the Spicy Challenge, like, that's a legit piece of hardware for $250. There's nothing wrong with it. It does not make bogus data. Yeah. So there was a question about a project.
Python projects. What was that? While Jody was speaking.
No, that was just 30 seconds ago.
Okay. So
please, Python projects to contribute to. Morgan, this is
yeah. So
trick.
We want people to first look at our two flagship projects. Check out EEG notebooks and check out Moab. Okay, these are, so EEG notebooks, as people know, is obviously, it's a good way to collect data, and primarily using BrainFlow or Muse LSL to get that. But in addition, right, we're using PsychoPy to display pictures or present things on the screen or present sounds. Okay, and that is also where people can make a contribution. So add some tasks, right? We are, I've been trying to, and this is kind of on the UC Davis people. They really got to give me some more information for me to finish the tasks from ERP Core, but I'd love ERP Core to be available as PsychoPy experiments. It's currently using Presentation, which is a poorly named tool when you're trying to Google it. But it's neurobehavioral systems Presentation. And this is a Windows tool for doing millisecond accurate display synchronized with experiments. They did this with a biosemi system. What we're able to do, and again, so EEG notebooks is this great project built on a number of on the shoulders of a number of giant Python projects, and so it's on PsychoPy, it's on BrainFlow, which is multiple compatible with multiple languages, but Python included, and yeah, and of course it's also using some M&E. And so the last part of EEG notebooks is you can contribute to some of the analysis that is possible with it, and it's definitely worth a shout out. So one of the visual spatial attention task was contributed by Kyle Matheson, and that it also check out, if you look at the Mac version in the old release, the Mac details would have links to Kyle Matheson's deep learning for EEG. Like, is it DLEEG? Anyway, hopefully, Alex is going to find us the link. So Kyle, github.com, Kyle Math, and it is for Matheson, not maths. It is deep EEG.
Although the project contains math, so
it does contain some maths, and so it's a great intro to using TensorFlow on EEG data, and together with he prototyped that with his brother who's at DeepMind, and
we can ask Manuel to verify this. But I've got one tip for you on using TensorFlow on EEG data. Don't. I'm just kidding. It's a pain in the butt. Anyway, it works great.
Well, I mean, this is so. Then make it easier. Let's have the. So I was putting, I was linking to Hubert's project when he and Yannick did the review of deep learning of your EEG, the systematic review or the literature review of deep learning for EEG. They put together a GitHub for going over the references, right? And anyway, I would love us to be the resource for people, like it's worth talking about Brain Decode, because of course the Brain Decode people have been great supporters of Moab, and also have done some great work in terms of the kind of data loaders that you need. I think, Alex would agree. So they and the other, I think, like the top two teams from the Eureka Challenge, even though, at this point, we should have all those projects should be available. Again, that was supposed to be the task. Now, I mean, Sydney competed 2 years ago with an IBM challenge on this, and I think their project is available, but I'm not sure that so much came out of it in terms of becoming useful, like generically useful tools for, I've got this new data set, I want to bring it in, anyway,
those are really lacking. And it feels like most projects get exactly there. I've got the data working, and then
a shout out to Brain Decode for sure, but the other project to look at is Moab, right? And Moab is if nothing else is a great intro to the kinds of algorithms that you use and how to use scikit-learn to do it. So it's also using M&E, but the M&E and scikit-learn people are very close, as are the NiLearn. So these are a lot of top French researchers are core scikit-learn developers, and but their day jobs are working in neuroimaging labs and MEG. Working on MEG, and so Moab is terrific. You can contribute data sets, because one part of it is just you're testing your algorithms against multiple baselines instead of just using one data set. This was great. I'm super sorry I missed it, but NeuroTechX India had another meetup just recently, and they had he joined us a year ago. Do you remember what was he working on? And he joined Muse, Anyway, he started working at Muse, and now I believe he's doing his PhD at University of Waterloo. And I don't know if Mayank was able to join us today, but he'd be on a plane right now. But anyway, Mayank was in, I don't know if you remember the high school student that joined us like a year and a half ago.
Yeah.
Building his own EEG system. Remember, he used like dimes, like
Mayank is an incredibly talented, and if you could buy NFTs and people that you think will do stuff, I would invest in the Mayank coin. Not that I don't, is a talented lad, please.
Yeah, it is. And so he went to work at IDUN. He started as an undergrad at University of Waterloo on site, and he is. I'm
Here, one second, let me mute. All right. Yeah, so the main things, just to agree, machine learning works great, and like deep learning is super cool and awesome. But if you're just looking to iterate on like classifiers, and especially if you want to mix multiple things, sorry, Morgan, I muted you, but please, yeah. So machine learning works great as you're testing like what types of models you're getting. And actually, just like in that other presentation, you can use the accuracy as a significant hint as to whether there's something in your data or not. And this is a little bit of like black magic type stuff, but if you trained enough models, you'll see that depending on how many classes you're giving it, if it's right at random, you're not giving it something or it's not finding it. And when you start to get models above 80%, it just tells you that there's something there, like how scalable the model is, how useful it'll be, how far it's going to train, you know, what it's going to take to improve it. All those are still mysterious. But if you see a model training to 80%, mess with it, iterate on it, mess with the data, whatever. You see a model that just won't improve above random chance, something's missing. So anyway, yeah, it was cool to see all those techniques put to use.
Yeah.
Presentation.
No, sorry, I'm reading the comments in the chat now.
Oh yeah, and my snark is part of the experience.
Well, it's funny that I was, explaining to Mayank that the French say it Moa BB, and I was like, but it's Moab.
Yeah.
And I had to actually give him a Wikipedia link for Moab in Utah.
Right.
But that would be the other great project. And together, I mean, this is what we want, is the kind of data sets that you can collect with EEG notebooks. We want to be, group data sets that are available in Moab, and that we can be looking at, the best ways to process those, or do kind of class detection, right? So just single trial class detection of, say, houses and faces or something like that, right? And that's what we had a nice talk with Sean from NeuroTech LA about trying to set up something where, even if we have to still do it online, these two projects are very online compatible. We can, people can collect data at home and still submit those for group analysis or group processing. And somewhat relevant, or at least, it was nice to see this week as well. It was the fifth anniversary of the Chan-Zuckerberg Initiative. And, they are, say what you want about the company, but CZI is an incredible supporter of open source software, open source scientific software these days. And so in addition to, an incredible amount of science that they displayed, of kind of, Allen Institute like um, just splendor. Some of these projects, just weren't getting done, right? And so they've got cell atlases that are again, like the only thing I can point to is something like the Allen Institute. But it was also great to see Fernando Perez displaying, talking about the latest and greatest from Jupyter, but he is also founder of IC, I'm not going to remember it now. It's like IC2C. Hopefully Alex is going to check for me, but this is Jupyter hubs that, so they will do your DevOps. They will do DevOps for you in terms of maintaining a Jupyter instance, Jupyter hub instance for you. And this seems like absolutely set up for, NeuroTechX as with our nonprofit status. Is this, we could qualify, and that would be maybe that's the way we could host our own, we could host the Temple University data and other large data sets and get them kind of pre-processed using this this service. It's like Jupyter Hub or Jupyter Lab as a service is what they're offering to nonprofits. And if we did use them, we would be supported by the Chan Zuckerberg Initiative. But check out czi.co/EOSS, I think, for essential open source software. Because I'm pretty sure they have Fernando as like an advisor on what software to support. And, he's of course basically supporting NumFocus and all the amazing projects that NumFocus and computational Python give us. I think it's czi.co. Is that what that expands to? It might be.
That's the URL that comes up on the grant page, Chan Zuckerberg. But it's in the
but if you want to check out, check out their YouTube. Allen Institute also did a symposium this week. Showing off. I think it was their I forget what they call their class of scientists or like early career researchers that are going to, change the world, and amazing group. And I think they call it Allen Institute Frontiers. Anyway, another great YouTube to see all the progress that's been made in single cell analysis and microscopy, and a number of other things that, again, like will hopefully change medicine by the time we get old, or pretty soon.
I know it's sort of a contentious topic, but these digital therapeutics seem like they're about to hit the market in a big way. So from music that lets you shift focus, that's Neurosity's claim, to stuff that lets you manage your depression, that's Divergence's claim. By the way, I'm not saying anything for or against it, right? These are just sort of
Sure. I don't think it's I'd be curious to know what you think controversy is. I do think there's a question of efficacy.
Well, there's a little bit of a catch-22 that we're putting these devices out there, but we're not like 100% sure that the devices or the treatments really do what they say they're going to do. So I think like one can say, well, we're getting a little ahead of our skis, in terms of selling stuff that we don't have the proof for. Not that I'm implying anything about these two companies, right? But I could see it argued that it's like, okay, we're kind of hoping that this stuff works. On the other hand, I would put my money on the thing being effective, and I think it's worth trying it. I think that this is a legit thing, so I'm on board with this stuff. I guess I'm just saying it seems like meditation was a single product application, but at this point, somewhere in the next year, like we're going to have people, the N10 from Neurable is also coming, which is going to be this interesting long recording EEG. I do think that, sorry to ramble, but basically, these types of devices let you do 8-hour, 10-hour recordings semi-passively, in the sense of, you're not wearing a contraption on your head and you can just do things normally. Or in the case of Neurosity, you are wearing a contraption. Yeah.
I'm curious about some things that I know started more than 5 years ago and I haven't heard from, So, like, do you remember, one, I'm so old. I remember when Google Health was going to get into mental health.
Oh, and then they did this glorious exit with the release of the Alice data set, and that was it. We're done.
Well, so not even necessarily with the X Labs, but Google Health.
Oh yeah,
had like 10,000 people with wearables and so one thing I did notice is that my insurance company this week, had the app tell me that if I gave it access to my Apple Health steps, I could earn money off.
How much money? Because I'll give you the same money for your data. Because I love it, right? These companies will give you 20 cents off your subscription if you give us. I'm like, I'll give you 20 cents for your data. But it's weird. I can't like buy cheap data like that.
Right?
No.
I mean,
I would love to contact Fitbit and be like, look, give me 500 people, de-identified. I don't need it, but let me just see their data.
Yeah, I know not everybody, certainly not everybody who's on right now is in the States, and not, so their countries don't have our problematic healthcare system. But I think it's really telling that, Amazon, what were the three companies? Amazon, Chase, and three ginormous companies created their own healthcare company, right, and then 3 years later disbanded it. Right.
That's not bad.
I mean, and Amazon, which could, it's its own economy, right?
So there are now exactly two things that are too horrific for Google to face down. Municipalities and fiber is a no-go. Forget it. Telcos are worse than anything Google else has discovered, and I can vouch for that. I worked for telcos for many years. And second, health. Health is just as intractable. Don't go there. There be dragons. Cut your losses.
That's nuts, though, right? I mean, it's really, really, yeah. So I will point people to the Open Data Lab in the UK. Okay, so this is Ben Goldacre's lab, who wrote the book. I think the book's called Bad Science, isn't that? I believe. Anyway, but these days he mines NHS data, and obviously, like a lot of medical people these days, he's somewhat COVID focused, but he also runs the site openprescription.net or org, which is an incredible resource too, right? Because he's.
May I? So this just showed up on my LinkedIn from Neurable, but I did think it was cool. Sorry for the LinkedIn flex. I couldn't figure out.
No. I'm talking about healthcare.
So I was looking for this. All right. Brief segue. We can go back to healthcare in a moment.
We don't have to.
There we go. Ramses. All right.
Oh, yeah.
This is it.
Yeah,
so this post. Yeah, well, I thought it was cool. Walter on our team said juggling increases his focus. So here's what I thought was neat about this. Obviously, whatever the visualization, but this discussion of can you do EEG with motion? By the way, they do have a Tavala oven. It's just hilarious. Sorry. I have one of those. All right. Anyway, what's cool is this location and algorithm, even though you have some head movement, clearly feels like it can get a signal. And right here, they're seeing a high focus state during this. I would love to check this for gaming as well. My assumption is there's some pretty high focus moments when people are anticipating something, waiting for something, or in the middle of like a difficult performance. So this is cool because juggling is probably more movement than we're going to get out of esports. And and I think this is pretty cool. But I do think it would be neat to have this kind of data on people coming to a workplace near you, a situation where your boss makes you wear the headphones and then yells at you if your focus score isn't high enough in a dystopian future.
So Brainco already got in trouble for this.
Did they really?
Yeah.
Oh no! Well, tell me about how this is happening already.
This is, I mean, not really, but
okay.
But it was students wearing in class.
Oh, you're kidding.
And and people ran with it in terms of imagining what else, what like a new level of intrusive monitoring, but and this is why I think it was Chile that passed something recently saying that your
or Portugal or something.
Neural data is your own.
Yeah.
And certainly, check out NeuroEthics channel where I post any links to events that are coming up. And I know.
Oh yeah, I'm sorry. Here's a photo of the Brainco thing that they got in trouble with. Not in trouble, but I didn't realize. Yeah, this is the. I'd seen photos of this one.
Yeah,
which I guess is the Brainco. Yeah.
It's them. Or certainly, Brainco's.
I have to tell you, yuck.
In China and in, I mean, it had the optics of, the F8 conference that Zuckerberg did, where he's like, everybody pull out an Oculus. It's like you don't really want to see a
you get a headband. You get a
1,000 people wearing something stuck on
this
there.
This is horrible in some way and awesome in some other way. Well, here it is, 2021.
But this is, goodness. It's very much, like how else do you, what other ways are you going to get at engagement and attention if not neural, right? Yeah. I mean, you can try and do what, say, Nielsen has been doing for, a long time, which is try and get it from a camera alone. But, honestly, I've got problems with the kind of face detection, attention, emotion detection, I know Raphael was talking about that.
I was going to mention that what's good in a car is bad if it's being applied to another paradigm, right? Because, I want to know your attention in the car, but maybe you don't want me to know your attention for something.
Well, and when the car is moving and you're in the driver's seat,
fair enough.
Like it's different than you're on your couch and like it's honestly my choice to look at the TV or not, right? Like, but anyway, it's like if you really want to get at attention or engagement, right? That obviously you need the neural, or
What about that mat if you're lying on your couch and your organs are vibrating just the right way, that mat would pick it up very accurately.
Yeah, I'm not sure what your organs would tell you, but I do want to get at that, and I wanted to point out one thing. So let me just so Todd Coleman. I mean, I think I posted this for us later, but I didn't make the meeting. Last, but it's I want to get Todd Coleman's site. So this came up for the electrogastrogram, and okay, so I forget now. Is he? I'm not sure if he's at UCSD or Stanford now, but this is the person that we're talking about. And let me see if okay, it says his LinkedIn says Stanford. So I don't know if I'm getting an older. Oh, okay. As of July 1st of this year, he's at Stanford. Okay. So, but here, let me just post his Google Scholar. Just because it is a you know, I think it would actually be one of a perfect application for free EG, in the sense of like you know, one nice thing about the torso is you don't have to worry about hair, and you can slap on a big sticky strip. But even better, just, get a bunch of electrodes to cover it. And there's actually the Auckland Bioengineering Institute in New Zealand has done magnetogastrograms. And so they cared about source modeling. And it turns out to be a great application for finite element modeling too. If, again, what we really want to get at are what are your gut neurons doing, and how does that relate to emotional and other measures, affective measures. Yeah, go ahead.
So big topic, but the gut stuff has been a thing in like non-traditional medicine. And depending on what part of the world you're in, there's a lot more weight given to that, or a lot less weight given to that, depending on your sort of cultural background and so on. It sounds like, it's gone from a little less mysticism and more into, no, there's particular interactions that we're looking for in the relationship with the gut. And I think this kind of goes into the microbiome and the bacteria. And again, not to get into the whole thing, but yeah. I would love to get a good primer on the relationship between the gut and cognition and whatever, because we work with these sports athletes and they think about their physical regimen, and we do actually monitor their brain state, right? So where would I go to get an initial presentation of like, here's the way your gut affects your cognition type of thing?
Yeah, I don't know. I don't know who would be the go-to person on that. I mean, let me go through. I'm looking at some of his papers. What I've learned from Open Humans is that it's difficult to do microbiome analysis.
Okay.
And that if you're taking a small sample of poop, that you
I was hoping to avoid.
Well, you're gonna get into poop if you want to get into microbiome stuff. And the thing is,
inferring.
I know, but
some non-poop metric. What if you have a sensor? Anything other than the comb and the stick? Come on.
Well, there are sensors that you can swallow, and that instead of sampling poop, instead of waiting for it to come out, sample from the gut itself, right? And so I know that some of Todd Coleman's equipment is have a device in the gut, have it get power externally, and communicate. So have an antenna,
right,
and
like
power for the device.
Put outside the
Yeah,
skin
that's sitting out here, and but it's really from the Innovative Genomics Institute. So this is the Berkeley Institute that has the Nobel Prize winner Jennifer Doudna. I forget how you pronounce her name. Anyway, the CRISPR Nobel Prize winner.
We got scooped.
And one of the things that IGI is talking about is how to do CRISPR on your microbiome, like how to do CRISPR at scale, right, and of course how to do sequencing at scale like that. In other words, how do I sequence 1,000 microorganisms, or how do I sequence 1,000,000 microorganisms, right? And these are all needed scaling, for microbiome analysis, right?
Well, I didn't really get how specific the resource needs of the brain are in terms of,
but this is, I guess what I'm trying to say is that one of the reasons that we don't, and that it's so hand wavy, is that we don't have the equipment to get at it, and that it's too much like correlative work on signals that we don't really understand.
Yeah, and I'm thinking maybe too far ahead, but I would love a scenario like this where we get somebody in and we figure out that like they tend to get fatigued earlier than their teammates on a team, right? Let's just say some of their teammates can maintain focus for 4, 5, 6 hours, but something around 2, 3 hours, they start to wear out, and it affects them more than other people. And obviously, without doing a stool sample, if you could sort of hypothesize, hey, maybe they're missing some bacteria in these colonies, or maybe we just give them like these supplements and we see if they respond, right? The ones that have the prebiotics and the ones that, I'm not really suggesting these, they're already working with trainers. So, I'm just looking at measuring the effectiveness of the routines they're already doing. But if we kind of take it to the final thing and say, if there's something about the way your body is processing resources, you might end up in a deficient state. And maybe the way that deficient state manifests is you run out of gas in certain situations before others. I think it would be neat to know what interventions would have a chance of modifying your digestive system in like a scientific way, right? I mean, there's so many, here, try this yogurt, try that bacteria colony, try this prebiotic, whatever. But I would love to kind of have an idea of like, here's the things we think people might be deficient in. Here's the treatments that seem to, emphasize those particular strains. Again, maybe it's too applied of a question. It just seemed something like I was very curious about.
Well, I mean, it's not necessarily what you're talking about, but I mean, I'm familiar with psychiatrists that have fed people special diets,
right?
That would be missing a particular amino acid, right?
Yes.
And then like only allow them food that is missing this amino,
Right.
And that will create a metabolic deficiency.
Right.
Okay. And then, like, what that gets at is how hard it is to experimentally create a metabolic deficiency.
Yeah.
Right. Is that somebody would have to be fed this kind of special crazy diet, right?
Right.
You know, like, again, like when you try and think about how to do this in a controlled setting where it's just like, I want to get people in, and in a limited amount of time, I want to create a metabolic challenge, right? It's hard stuff. The other way in which people have done it is, and this is, it's actually a special technique for magnetic resonance spectroscopy,
Mm-hmm.
but allow people to come in, feed them, give them glucose that has a particular heavy carbon.
Mm-hmm.
Okay. And that's something that we can track that, in terms of, like, now you're processing that carbon and we can kind of see that. But again, these are techniques for studying metabolism.
Right.
And yeah, so, I mean, I again, like, I think these are great. If somebody's got references, please let me know.
Right.
I'd love to, I have the same questions, or certainly, one of the reasons that we put things like doing microbiome testing into these psychiatric grants that were trying to automate diagnosis was that, like, I want to know what you've eaten for the last month, right?
And actually, this really gets at something that I've been curious about for the longest time. And again, maybe this is a little tough to cover on the call, but looking into those special diets, one of the diets that they do for people that have epilepsy or diabetes or just weight loss is those ketogenic diets, right? And for epileptics, they go like hardcore. They say no more than like 15 grams of carbs a day, but it really helps with the seizures. So there's something very specific about that diet, because your body produces this thing called ketones, and then your brain can either use glucose or ketones, which actually sounds like a pretty interesting thing, because in your normal state, you only have glucose. So that's all you're going to use, and that's fine. And it's perfectly sufficient for the brain. But it seems like there's some interesting research that ketones are a slightly more flexible thing than glucose. And it allows your brain to kind of do, with glucose, it has to throttle up all the way, because like a glucose molecule is 9 calories, but with ketones, it's a smaller unit of calories. And so it can, anyway, where can I read about brain conversion of glucose and potentially ketones into neuronal energy, or, that type of thing?
Yeah. So I would want to see a study,
right,
that like labeled carbon in a way that showed that those ketones were actually being used, because again, it is super easy for a metabolic story
absolutely,
to be told.
Yes.
That actually only plays out in the muscles and doesn't play out,
or in some very limited way,
or it's a super limited way. And so it was actually this lab down in Pasadena. They weren't, I don't think they were officially part of Caltech, but they were like in a building next door to it. And I'm blanking on his name, but this is where I did my MR, magnetic resonance spectroscopy training. What's okay, I'm really old. This was like 20 years ago, and British guy. It will. I'll look it up later. It's pretty hard to show this. I mean, like you need to do something. You know, if you want to convince me that just because you're eating something that, you know, chemistry says will produce this, I would still want. I would want to show that it gets actually used by.
Here's a PubMed link,
great.
but I'm not familiar enough with papers to kind of assess whether this is, you know.
I will check it out.
But basically, what I had ran across was saying that that it's a different kind of fuel, and that the brain prefers ketones if it can, but will use glucose and whatever. Yeah, sorry, go ahead.
So this is cool, right? So they're using PET. I mean, PET's one of the ways that, you know, PET is a flexible imaging technique that really you can use your knowledge of organic chemistry to make the make the contrast something of chemical interest, right? So this is the technique that you use to, say, image neurotransmitters or other things, or there's some particular compounds that people use to get at amyloid betas and tau proteins in Alzheimer's, for instance, right? It's like ground truth is considered PET imaging. So that's a good sign. Anyway, you know.
So it just seems like an interesting thing. There's, you know, where I'm kind of going with this is that I think glucose is a little more food dependent, and ketones, it seems like the body can generate at will by breaking down fat stores, which really makes me wonder, like for longer endurance type tasks, like when they're looking at those chess grandmasters that burn through 6,000 calories a day while seated at a tournament, you know, I assume that that's quite a lot of cognition that your brain is going through, and that's quite a lot of energy that it's using. And it just feels like in terms of resource availability, I wonder if you needed to do 10, 12 hour, it's just a study that I hope to do. But basically, if you're doing 10, 12 hours of chess, gaming, studying, lecturing, whatever, something really cognitively intense, do you have more either perceived or measured endurance if you're on a ketogenic diet than if you're just on a regular diet? That's sort of my curiosity.
Yeah, this is definitely not my area. You know, if anything, I mean, what I can tell you is what my brother has told me, who's more, you know, cares a lot more about these kinds of things, and there's certainly a lot of bad science out there. You know, I mean, there's a lot of people selling diets, you know, because it's easy, right? Now, that doesn't mean that there's not good science. It just means that there is a hell of a lot of chaff that you need to get through. But
I would just love to understand how the brain uses fuel to process. Like how do you know? I understand every time it's like ATP based and whatever, but
again, it's just getting back to how would you do the study, you know? And so
I'm just trying to get like a conceptual overview of like, here's how the brain uses glucose to do stuff.
Oh, well then just look at, I mean, then check papers from Yale that are doing cerebrovascular coupling and magnetic resonance spectroscopy.
Okay.
Right? They are very much giving you a chemical, sorry, I see the, if I see the name, I'll be like, oh yeah, that's the person to. Like his advisor was Roth. Hyder, yeah. So yeah, Famid Hyder. I mean, like, let me just give you, I mean, as an example of that kind of, you know, yeah, and Rothman. So Rothman was the last author. This is like 10 years ago. I'm sure there's more up-to-date stuff, but if you want to look at how, this is getting at like astrocytes, glia, neurons,
Okay.
and
Perfect.
and maybe not exactly, like I might not have picked an MRS paper.
Yeah, I'm
but
really interested in this like mitochondria glucose thing, but I'll Google around.
Well, I mean, check more papers by Hyder.
Okay.
I mean, if you want to see somebody doing, doing magnetic resonance spectroscopy for this kind of neuroenergetics,
right?
Because that
Yes,
is
that's exactly it.
Yeah, I mean, and again, like these are the kind of animal lab, imaging people you want to see. Although honestly, to really get at your questions, you don't need to do non-invasive. So there's potentially better stuff that's not non-invasive, but this is where I was like, oh, as a because I was trained as a biochemist, molecular biologist as an undergrad, right? And so I was like, oh, wait, these guys are actually doing chemistry. And so and these guys are giving me like rate equations and things that that I can model, like numbers that I can model. Like when we looked at kind of fMRI is a really muddy measure, we'd say, right? Because it's not just the blood oxygenation. And so to actually tease apart so that you're doing chemistry with fMRI, really hard. And one of the only people I know doing it is Dan Bolte back in Oxford, and he's doing it by basically having you wear a gas mask and controlling your oxygen CO2 ratio.
Good Lord.
And it's it's the one experiment that I've opted out.
Yeah,
during the experiment because I thought I was suffocating.
You chose wisely, Morgan. Anyway, I agree on that one. Sorry, folks. I know I filled out the questionnaire, but
it's
a journey together.
I was in the scanner.
Yeah.
I had the
that's what I mean. Sorry to mess up your thing. I'm out, folks.
Yeah, get somebody else, man. I think he's doing a little bit of that here. Mm-hmm. Oh yeah, JJ Riera too. I mean, is the kind of, I mean, again, this is more invasive rat work, but I really want to get at these questions of, I mean, the psychiatrist, I think his last name is Salmon, and he used to be at University of Arkansas, Little Rock. But he was doing resting fMRI with this amino acid knockout. Like, so like there's some amino acid that if you see if I can find anyway, I'd really like to find that work because I've not seen anybody try that, and it was hearing a radio show on biohackers, and have I talked about this before? It was like there was like a nurse like up in Seattle or like in Washington State, and but biohacker, and was just like, because I'm a nurse, I feel like I knew what I was doing, and he like I think he was like overdosing on a vitamin or missing a vitamin. No, I think he was giving himself a vitamin deficiency,
right,
by having a particular diet, and it reminded me of the salmon studies. But that was where I was like, you've got to have the real dedication to get at these, tease apart these metabolic, or kind of do it in a really targeted way, because it was kind of the pain people who are using these lasers to elicit pain are like, hey, look, if I just hit you with a hammer, you're getting all these different types of pain receptors being active at the same time, and it makes it really hard to get at this experimentally. If we use a laser at this frequency, then we can just get this particular kind of pain receptor, and and now we can start teasing this apart. Metabolism's much worse, or much harder. And anyway.
I guess when I was thinking of the metabolism as fuel for the body, it was less interesting to me, but obviously the brain is part of the body. And so that's just been a more interesting. So I love the discussion, Morgan. This was super cool. And I do plan to dig into it some more. I'll let you know if I find anything interesting.
I since I mentioned egg last week, I put in a link. So next week I will try and have some better gut links and interesting metabolism challenges. But yeah, I mean, this is like Jody was doing, it's like we want to know how the person's been eating for the past month, right? Some of these changes are also really slow, and so it's like if they've started eating well a couple days before you see them, but they haven't been generally for that month, right? Like, getting at like what's in their stomach, right then isn't helpful. How can I track that? Some really interesting work is happening in terms of the inflammation hypothesis, or at least with depression. But some of that's also come from new tests, or having tests more widely available, low cost, so that people can be testing themselves every day at home. I want to know those tests.
Me too.
and I want to, like, this is one the proposal that I made to Open Humans was my spectrogram, right? Was like just getting a daily foof on yourself, but being able to then do the same thing that Russ Poldrack did with his My Connectome project, which is daily inventories. What did you eat? How much did you exercise? And look at that every day for a year, right?
Yeah.
Because the effects that we're looking for potentially are that slow, where we need that long a period of time to be able to say anything. Yeah. Okay. Anything more in chat? And oh, that's awesome. I'm glad Alex Peak joined us. I would love to catch up on gaming, the Unityverse.
There's a developer who's been posting on NeuroTechX. His name is, or their name is Maru. Sorry, I have a feeling that we have an excellent opportunity somewhere in the next few weeks if we organize it to get Unity and EEG and do a little bit of the demo and talk to people about that. I think it's definitely worth having a hack night on. So maybe we can pull that stuff together. I think it'll be a good one.
That's why I wanted to ask Jody if that was like something that we could build on, because I think a lot of people are like, well, I've got some Unity experience, but building that framework,
that's the stumbling block, and nobody knows what to do with the analysis piece. But if they had answers coming at them, then they could match on them.
And if she's already got the LSL and stuff,
oh yeah, we can just pipe it.
She's already thinking about the kinds of things that we would want.
And Maru ran into the online versus offline thing already. So M&E is not designed to inspect any real-time streams, and it doesn't like it. And yes, of course, you can record and then stream back and do all that other stuff. But these are the kinds of limitations. Like, people want to do something online real time, and it's like, yeah, you got to write your own. So I think we can add a lot of value by diving into that.
Yeah, definitely. Okay, but we will let's push on John to come back and talk to us about the data challenge.
Let's do it. Next week is data challenge, and then the next hack night after that we'll do some meetings.
Okay. Take care, everyone.
All right, thanks for joining us tonight, everyone. This